Hello, I am Kaveya Sivaprakasam and this is the demo lecture for the TA application. I am an incoming MSDS student at UCSD. So let us dive into the topic. Today I will be teaching DBSCAN. DBSCAN stands for Density Based Spatial Clustering of Application with Noise. I understand it sounds very complicated, but I will explain it as simple as possible. I want to quote something before starting. DBSCAN will cluster like humans can. So okay, imagine we have a set of data points and we have plotted on the x and y axis over here. So as a human being, one look at it, I can tell you that we have two clusters over here. Cluster number 1 and cluster number 2. But there is a chance that if we had used a standard clustering method like k-means, we might have not received the expected output. There is a chance that we would have got the cluster that might look like this. Why is this happening? Because these two clusters are nested clusters. What does it mean? One of the cluster is wrapping around the other cluster. So DBSCAN is coming to our rescue, and let us see how DBSCAN works. Before jumping into it, before we start clustering, three things we have to keep in mind is, first, classify all the points. We will classify the points into three categories: core point, boundary point and the noise point. I will explain what these things are. Second point is to remember the input parameter. The two parameters that we are supposed to keep in mind is epsilon and the minimum number of points. And the third, most important, is the condition. What is the condition for? To decide whether any one point is a core point or not. Let us take an example. Imagine I have taken a point A. First step we will do is draw a circle around it. We will draw a circle around it. What is the circle? This circle we have made has a radius of epsilon. Understood? We are drawing a circle around the point having the radius epsilon. Epsilon and minimum number of points are user defined. Over here I am taking an example of 1 unit. Let us imagine a scenario. I will just draw a particular number of points around this. 1, 2, 3. Let us just take this example. Okay, over here I have taken this point, drawn a circle around it, and now we will count the number of points present in the circle. How many points are there? 1, 2, 3. You understand what we are trying to do over here? As the name suggests, density based clustering, we are just trying to see the density of an area. Like, the density will be considered to be high if the number of points in the given area is high. Simple. So here we are counting the number of points present. 1, 2, 3. The number of points present is 3. Now what is the condition? The condition is if the number of points present in this circle is greater than or equal to the minimum number of points. If it is greater than or equal to the minimum number of points. The number of points present is 3. It is equal to the minimum numbers required. So this will satisfy the condition and hence it is a core point. Hence it is a core point. Similarly, we will do the same example to the second point over here present. Again we do the circle, number of points present, 1, 2, 3, 3 points are present. It satisfies the condition, hence this is again a core point. Got it? Again, point number 3, we will again draw the circle of radius epsilon, count the number of points present, 1 and 2. Is it satisfying the condition? No, it is not satisfying the condition, and hence this is not a core point. So it has two options: either it is a boundary point or it is a noise point. How to identify whether it's a boundary point or a noise point? If one of its neighbor points is a core point, then this point will be considered as a boundary point. This is a boundary point. Understood? We understood how to find a core point, a boundary point. Now let us find if the point is a noise point or not. Again we will consider the fourth point. Same condition, we will draw the circle around it of radius epsilon, count the number of points present. Only one point is present over here. It is not satisfying the condition, so it is not a core point. Now we have to decide whether it is a boundary point or a noise point. Is its neighbor a core point? No. its neighbor is not a core point, and hence we come to the conclusion that this is a noise point. We understood how to classify a particular point as core point, boundary point and a noise point. Simple. Now we will start forming the clusters. We have decided whether a particular point is core point, boundary point and a noise point. We will take one of the core points and assign it to the cluster number 1. And now we will extend this core point to the other core points, and we will keep on adding those core points in cluster number 1. So we are adding this all the nearby clusters, all the nearby core points into cluster number 1. All will be added to cluster number 1. And similarly, we will reach to the point where we will reach the boundary point very soon. And we will add the boundary point in the same cluster its neighboring core point exists into. Perfect. So if we take this boundary point, since its neighboring core point is present in cluster number 1, this will get into cluster number 1. Simple. This will enter into cluster number 1. Now we have come to the conclusion, we have ended the cluster number 1, as we cannot extend further. We cannot extend the core points further. But still the core points are still remaining, which has not been assigned to any other cluster yet. So we will again take one of the clusters, one of the point of the other core point, and we will assign it to the cluster number 2. We understood? We have started with cluster number 2, and similarly we will be extending this core point and we will be adding it into the cluster number 2. We will extending it, and that is how cluster number 2 is formed. That is how clusters are formed. It's very simple. And again, I have tried to explain DBSCAN as easy as possible. Again, I would like to quote what I said initially. DBSCAN can clusters like humans can. Thank you so much for listening to me, and I hope I get the opportunity to give more lectures like these. Thank you.